Hi guys, this is going to be a video on ionic bonding. So ionic bonding is what happens when two atoms transfer their electrons to each other, right? So for example, if we have sodium transferring its 1 valence electron to chlorine with its 7 valence electrons, right? What you'll notice is that sodium is left with 0 electrons in its valence shell, or 8 electrons if you consider its lower noble gas, and it's going to be left with a positive charge. Chlorine, on the other hand, gains 1 more electron, and so now it has its full 8, so now it's happy. It has a minus charge. And so this plus and minus charge here, right? Because of the transfer of the electron, well, they're going to be attracted to each other because opposites attract. And so the bond that forms between the two atoms form because of that electrostatic attraction. Okay? So, sorry, the plus sign should go out here. So, we have a sodium atom attracted to a chlorine atom, and we have an ionic bond. Okay? Note that sodium has a very low electronegativity. Chlorine has a very high electronegativity, and you can look at the periodic table and find that would be the case. Okay. Speaking of the periodic table, right? So if we look at the periodic table, what we'll find is that, well, there's a lot of different um, elements on the periodic table. And so how do we tell whether an element will form an ionic bond or not? Well, you can just look at whether it's a metal or a non-metal, right? Metals are over here on the periodic table, right? All the way on the left, right? And non-metals are on the right. So all of these elements over here. And so, looking at the periodic table will help us form those ionic bonds. If we have a bond between an element that is a metal and a nonmetal, then we'll most likely form an ionic bond. The one exception to that is hydrogen. Hydrogen will act like a nonmetal. Okay, hydrogen will act like a nonmetal. Right. So, with ionic bonds, we are focused on the charges that each of these elements make, and the charges are based on the number of valence electrons it has. Okay, so elements in group 1 have 1 valence electron, and because they have 1 valence electron, they're going to try and lose that electron. Right? They're going to try and lose that electron, and so what happens is they will gain a 1 plus charge. Elements in group 2 have 2 valence electrons, and because of that, they'll try to lose their 2 electrons, and they'll have a plus 2 charge. We're going to skip all of the transition metals. Those don't act, when we add electrons to those atoms, they don't add to a valence shell, so we can skip those. Group 13 elements have 3 valence electrons, so they'll try to lose 3 and form a plus 3 charge. Carbon has 4 valence electrons, and it can go either way. It can lose 4, or it can gain 4 to get its 0 or 8 valence electrons. And so this could be plus 4 or minus 4, depending on the bond, right? With nitrogen, there's 5 valence electrons, so instead of losing 5, that's very hard, it's going to choose the easier path, gain 3. Oxygen has 6 valence electrons, so that's a 2 minus charge. 7 valence electrons for fluorine, needs 1 more, it's going to lose 1. And because the noble gases have 8 valence electrons, they don't participate in ionic bonding. Okay? So, using that information on the periodic table, we can start to combine different elements together and form ionic compounds. And so, if we look at sodium, right, that's how I knew that it had a 1 plus charge. And that's how I knew chlorine had a 1 minus charge. Let's say we tried to react magnesium together with chlorine. What would the resulting compound be? Well, So the first step here is to find the charges. If you look at the periodic table, you'll find that magnesium always forms a +2 charge, and chlorine always forms a 1 minus charge. Second, you want to make sure the total compound's charge adds up to 0. Okay, and so what does that involve? Well, if we just stuck magnesium and chlorine together like so, what we would find is that the total charge, Q, is going to be 2 plus minus, or I should write +2 here, +2 minus 1, or +1. Since there is a overall net charge, we can't just stick one magnesium together with one chlorine. Okay, so that's no good. So in those cases, we're going to use the cross charge method. Okay, so what happens is the charge on the positive ion becomes the subscript of the negative ion. The charge on the negative ion will become the subscript of the positive ion. And so if we do this, we get magnesium chloride. Magnesium chloride, MgCl2. If we look at the charges there, well, we have one magnesium. So we have one 2 plus charge. Okay. And we're going to subtract two 1 minus charges. Okay, so two 1 minus charges. So what happens is we have 2 minus 2, or 0. And indeed, we have that. The cross charge method will work as will work for basically all of your compounds. And so when we react magnesium with chlorine, we will get magnesium chloride. Okay. One final thing to note is that the name of this compound is magnesium chloride. Okay. So that chlor comes from the elements, so chlorine. The "ide" ending, this indicates that this element has taken on a negative charge. All right. So magnesium chloride. All right. So that's it for this video. Take care.